they would give us just a list of numbers in a sequence, and we would have to determine if they had a constant difference or they had a constant ratio or something like that. And the way that we looked for that constant ratio was we went through and we said second term divided by first, third term divided by second, fourth term divided by third. If we got the same answer each time, we said that we had a constant ratio. And so that's exactly what happens in the first couple of examples here. They ask us to tell whether the sequence they give me is geometric or not. So I can go through and I can say, okay, 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So yeah, I have a constant ratio of 2. So yes, this is geometric. Whereas if I look at the next list, if I go through 4 divided by 1 is 4. 9 divided by 4, not 4. So if I don't have that constant ratio, then all I'm going to say is that no, this is not geometric. If I do have a geometric sequence, I now have a formula for creating the nth term of a geometric sequence. And that formula will be a sub n is equal to a sub 1 times r to the n minus 1. So all I'm going to need is my first term and my ratio, and I'll be able to create the formula, just like when we were working with our arithmetic, we needed like our first term and our constant difference, right? So for example number 2, they tell me if your first term is 3 and your ratio is 2, find the first 5 terms of the sequence. All right, couple of ways that we could go about doing this. To begin with, we could create a formula where we go through and we say, okay, my first term was 3, my ratio was 2, so according to that formula they gave me, that would be first term times ratio to the n minus 1, that would be 3 times 2 to the n minus 1. Can I simplify that down to 6 to the n minus 1? Can I simplify 3 times 2 to the n minus 1? Can I simplify that to 6 to the n minus 1? No. Right, the n minus 1 only applies to the 2. It doesn't apply to the 3. I cannot combine those. But I promise you that when you have a quiz over this material and you're looking at the multiple choice possibilities down there, one of them, if it were this problem, would say 3 times 2 to the n minus 1, and one of them would say 6 to the n minus 1, because I need to know whether you can combine those or not. Now I have a formula, so now I'm right back to what we've been doing since section 9.1. If I have a formula and I'm asked to find several terms, then I can just plug in, right? So I could go through then and I could say, okay, let's plug in 2 into that formula. So if we put 2 in the place of n, we'll come over here and put 2 in the place of n. So that would give me 2 to the 2 minus 1, which is just 2 to the 1. So 3 times 2 would give me 6. All right, go ahead and find your third, fourth, and fifth term. Plug those in, find your third, fourth, and fifth term. All right, what'd you get for your third term?
6, 12.
12. What'd you get for your fourth term? What'd you get for your fifth term? 48. Perfect. So we could plug into the formula to get those. After we work with geometric sequences and series for a little bit, we'll start to notice a few things about them. Like, notice that if you want to move forward in that sequence, you can multiply by your ratio. Like my ratio is 2, so I could say 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. If I want to move backwards in the sequence, I can divide by my ratio. So I could say 48 divided by 2 is 24, divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. So that's really helpful for the problems like we were working with yesterday. Remember when they would give me like a fourth term and I had to move backwards to my first term, or they gave me a fourth term and I had to move forward to my 13th term or something like that? That's helpful to know then with a geometric. If I multiply by my ratio, I can move forward through the sequence. If I divide by my ratio, I can move backwards through that sequence. All right? Look at example 4. For example number 4, it says, find a formula for the nth term of the following geometric sequence, and then find out what the 9th term is. And they give me 5, 15, and 45. Now, they were kind enough to tell me that this is geometric, but they didn't have to. We could have gone through and said third term divided by second and second term divided by first and see if we have a common ratio. But they did tell us that this is geometric. This is just like that example yesterday where they told me find the 7th term. And we said there was kind of like a hidden question there where you first had to find out the equation for the sequence before you could then plug the 7th term into it. For this one, they also were kind enough to go ahead and say, hey, you need to find the formula for the nth term first, and then plug in to find your 9th term. All right, so let's create a formula. We can come down here and say, what is a sub 1? 5. What is my ratio? 3, because we could say 45 divided by 15 is 3, 15 divided by 5 is 3. So that gives us everything that we need to complete our formula. Put 5 in for a sub 1. Put 3 in for R. And then we also could find our 9th term, right? So let's plug 9 in for N, and we've got our 9th term. So at this point, we've learned the nth term of an arithmetic and the nth term of a geometric. Yesterday, we also saw the sum of a finite arithmetic. That was an arithmetic series. So it makes sense. The next thing we would see would be a sum of a finite geometric or a geometric series. So they tell me that if you have a finite geometric and you want to find the sum of that sequence to make a series, that this is the formula that we would use. The best part about that formula is what is not in it. There is no a sub n in that formula. When we did the sum yesterday, that was the one that, remember, it was like Gauss had discovered it when he was 10, and we had to have the first term and we had to have the last term, right? And it was like 2 problems in one every time we tried to do the sum, because we had to turn around and go figure out what the last term was before we could even put it in the sum formula. There is no a sub n in this formula, so I won't have to do 2 problems in one when I do a geometric series, okay? So example number 6, it says find the sum of 4 times 0.3 to the n, and they want me to start when n is equal to 1, and they want me to stop when n is equal to 12. So that's finite, right? I have a stopping point. I'm only using 12 terms, so that's a finite number of terms. So I need to check and make sure that this is geometric so that I know that I can use that geometric formula. I don't even have any numbers. How am I supposed to tell if it's geometric? Okay, let's get some numbers. Let's go through and plug in 1, plug in 2, plug in 3, plug in 4, whatever you need to. Plug in some numbers. Plug in so we can get some terms, and we can see, are they arithmetic, are they geometric? What are they? What am I working with? All right, so when we plug in 1, we get 0.3 to the 1, so 4 times 0.3 is going to give me what? 4 times 0.3, 1.2. That's going to be my first term, 1.2. Then I'm going to need a ratio. So we could go through and we could say, okay, second term divided by first, that gives me 0.3. Third term divided by second, that gives me 0.3. Fourth term divided by third, keep right on going, that gives me 0.3. So I can plug 0.3 in the ratio in the top and the bottom. The hardest part about finding the sum of a geometric sequence is typing it correctly into my calculator. So grab your calculator and put this in, and we're going to see if we can come up with the right answer. So now that we have it set up, let's see if we can type it in correctly and come up with the right answer. If you have the new operating system, remember to use that fraction button. Makes your life so much simpler. That's the alpha y equals to get to your F1 menu. The very first option there is the thing that actually writes a numerator over a denominator so it looks the way it's supposed to. Then you don't have to put in 57 sets of parentheses. All right, so let's see how you did. You should have gotten 1.714. It keeps going on from there, but 3 decimal places is sufficient. 1.714. If you did not get that, it's just because you're not typing it in correctly, and that's an easy mistake to make because of all the parentheses that you have to put into this thing. All right? If you have an 83 or you have an 84 where you haven't downloaded the new operating system yet, you're going to need to type it in this way. So if you're not getting the right answer, check and make sure that you have all of the parentheses in place. Again, much simpler if you have that new math print on the new operating system, because we can type 1.2 parenthesis and then we can hit alpha y equals, which is F1, hit the very first option there, and it literally builds a fraction for you of a numerator over denominator so you can type it in and it looks right, so that you can tell that you're putting it in correctly. All right. So that was the sum of a finite geometric sequence. We also have the sum of an infinite geometric sequence. Now, at this stage, you have all these formulas spinning around in your head. So I tried to sum them up for you here on the top of the page for section 9.3b. These are the formulas we should already know. Nth term of an arithmetic, sum of a finite arithmetic. Nth term of a geometric, sum of a finite geometric. This is the sum of an infinite geometric. We've already seen that we can find the sum of something that goes to infinity, but only under very particular cases, right? Like it was like a repeating decimal or something like that would be when we were able to find it. So here are the criteria for being able to find an infinite sum. Number 1, it has to be geometric. And number 2, the absolute value of the ratio must be less than 1. Has to be geometric, and the absolute value of the ratio has to be less than 1. If those two things are true, then I'll be able to use this formula to find the sum of my infinite geometric. All right, so look at example 7. For example 7, they give us the summation from 1 to infinity of 4 times 0.6 to the n minus 1. So I need to make sure it's geometric. I didn't even have any numbers. So the first thing, of course, I have to do is get some numbers. So let's plug in and find some terms. So I've started with 1 since that was my lower limit of summation. And when I put in 1, 1 minus 1 is 0. What is 0.6 to the 0? 1. Anything to the 0 is 1 other than 0. 0 to the 0 doesn't exist. But anything to the 0 is going to give me 1. So when I have 1 minus 1 there and I end up raising it to the 0 power, then I just get 1. So that's why here we have 4 times 1. All right? Then we're going to plug in 2. So if we do 2 minus 1, then that's going to give me 0.6 to the 1. And then we plug in 3. 3 minus 1 is going to give me 0.6 to the 2, and then 0.6 to the 3, and 0.6 to the 4. We could just keep right on going. So again, in order to use that handy dandy little formula, this has to be geometric, and the absolute value of the ratio has to be less than 1. All right, well, let's start with, is it geometric? I'm going to take my second term and divide it by my first. Third term, divide it by my second. You can keep going if you need to, but yeah, absolutely. I have a constant ratio of 0.6. Number 2, what is the absolute value of 0.6? 0.6. Is that less than 1? Yes, so that second criteria is also met. The absolute value of my ratio, 0.6, is less than 1. So yes, I can use this formula. This is about the simplest formula we're going to get, right? First term over 1 minus the ratio. That's it. That's all there is to it. So what was our first term? 4. And we've already said that our ratio was 0.6. So if we do 1 minus 0.6 in the denominator, that'll give us 0.4. So 4 divided by 0.4 would give us 10. That would be the sum of that geometric series. All right, look at another one. 3 plus 0.3 plus 0.03 plus 0.003. So again, got to make sure it's geometric and got to make sure that the absolute value of the ratio is less than 1. All right, so let's start with, is it geometric? I can go through and do second term divided by first, third term divided by second, get the same thing every time. Yes, it's geometric. Ratio is 0.1. What's the absolute value of 0.1? 0.1. So the absolute value of the ratio is less than 1. So we're good. We can use our formula. So we're going to have first term over 1 minus the ratio. So first term was 3. Ratio was 0.1, so 1 minus 0.1 would give us 0.9. Now, we're not real fans of decimals inside fractions. So if you want to get rid of that, you could just multiply top and bottom by 10. If you multiply 3 by 10, you get 30. If you multiply 0.9 by 10, you get 9. And then your decimal's gone. So then you can write 30 over 9 in a variety of ways. You can leave it as an improper fraction in lowest terms. You can write it as a mixed number. You can write it as a repeating decimal. So a couple of different options there. All right, look at the last one. Again, they give me another sequence, and they ask me to find the sum, and we can tell by the ellipsis dots that it's going on to infinity. Got to check and make sure that it's geometric first. So sure enough, I get a constant ratio of -2. Then I need to check that the absolute value of the ratio is less than 1. So what's the absolute value of -2? 2. Is that less than 1? No. I stop right there and just say no sum. If you want to be really impressive, you can say it diverges. And that just means that it's not all converging down on one particular value, one sum. It's kind of going off in a couple of different directions. So no sum if those two criteria aren't met.